So let's see what we have achieved. So what we have achieved is we have deployed a Kubernetes cluster on AWS. Inside that, we have installed Kserve, we have inference servers, we have mlflow servers and ML servers. And we train the model on a toy dataset. We do hyperparameter tuning. We use mlflow experiment tracking, which is also deployed in the Kubernetes cluster. So we'll see everything step by step. So first one, basically we are having nodes which are running, and you can see that this is a host name inside of Kubernetes, the case of host. And then we have data here, which I will show you soon enough. Then we have this load balancer endpoint, which can be used uh, as an mlflow server for a Docker image, which we have. I'll press enter and we send a request and it gives me a prediction. Similarly, I could also use a V2 protocol, which is basically a ML server based endpoint. And that also gives us a prediction, which is the same, right? The values are the same. And next is what is this data? Let's see that. What data looks like. So first, it's a dictionary inside which we have a data frame split, which is again a sub dictionary. Uh, it has a key called columns, which is a list of all the features in the model. And then there's a data key, which has again a list of all the features which are the input to the model. And this is the input to my endpoint, and it gives me a prediction. Similarly, there's a different format for ML server, which is basically like something like this, which has a dictionary and it has an input, which is a dictionary of a list of dictionary. And the data is kind of the same. It is just that uh, this is what we are using. So seeing the results are also the same. So this is as simple as that. We also have like a, okay, let me clear it up a bit. There's also a test inference.sh, which can do the inference on our behalf. See, this was a prediction. It shows you a couple of things like what is the prediction URL, what is the external endpoint, what is the request which we are running. Actually, this is not exactly the request. This is just the endpoint. So this is the deployment information, external URL, which is the load balancer URL, the namespace, the inference service, the host name, and how we can use this information to test our cluster. So we can run a curl command with this host, with this header, with this data, and this endpoint, and it returns me a result, which is this prediction. Similarly, we have one for ML server, and it's kind of the same thing. It's just that the endpoints are different. Again, you see curl, the host name, which is the same. It's that the endpoint is slightly different, but it's the same. And that also gives us the information, right? It gives me an answer. And it also gives us some useful commands. For example, you can check the status of the inference service and see the state and stuff like that. It gives you some information. It has been running for 5 hours. If you want to view the logs, you can see it by using this command, the last few logs. And it's showing that we have sent some post request. Some of them are for this invocation endpoint, which is basically the ML server endpoint, sorry, ML flow server endpoint. And these post V2 endpoints are basically ML server V2 endpoints. And these are the logs. The describe command, and let's see what it does. See, it describes the service, right? There is the namespace, it's the name, label is done, annotations, version, which is kserve, serving, the kind is inference service, creation timestamps, and stuff like that, right? The specifications. See, this is the Docker image which has been used. And just by changing this Docker image in a YAML file, I could redeploy easily and it just updates. I'm using this 600 milli cores. So 1000 cores is equal to one CPU. Sorry, 1000 M is equal to one CPU. Memory, stuff like that. The URL is the internal one. Anyways, it has a lot of useful information. I'm also kind of new to this, but we have seen this demo, which kind of is helpful. Okay, so what have we done to achieve that demo, right? So this is the workflow. First, we create an EKS cluster. We just run a script. It takes 15 to 20. Actually, it took 25 minutes for me. Then we install a load balancer controller, which takes a couple of minutes. Then we install Kserve, we set up S3 and IAM permissions. That's basically infrastructure phase one. Next part is model development. So we have a Python code which uses mlflow experiment tracking, and we train and do hyperparameter optimization, which kind of runs locally. We use mlflow endpoints, which is hosted on Kubernetes. We register the model, we build and push the Docker image to our Docker repository. Next part is basically the inference deployment, which is basically the use of this Docker image to deploy an ML server to Kserve inside our Kubernetes cluster. We wait. When it's ready, we test the endpoints. We can also do all kinds of monitoring and stuff like that. And then we have a cleanup script which will kind of destroy all the assets we have created. So although the demo looks kind of super simple, it's not. But I started this with a goal in mind that this is the infrastructure I want to build. And that is one part, right? The second part is actually checking out the URIs. Again, what we'll do is we'll just go to a browser anywhere. And because these are reasonably good machines, it opens MLflow really quickly. Because I actually used a T3 micro to host MLflow myself, and it was pretty slow. Anyways, so we can see this wine quality 2 experiment. This is what our experiment was. This experiment which does hyperparameter tuning and model automatically, sorry, the experiment tracker automatically just push the top five. So this is hyperparameter tuning MLflow run, and it has the top five runs. You can open it further, and you can see the artifacts, which is this results for all the possible parameter combination. I don't think I can screen this, but okay, let's expand this. So you can see it has the rank, mean, and standard deviation of the test score, right? And there are many of them, 100 of them, right? Another interesting thing to see here is this file is in this S3 location, which is also created by our setup script. This S3 bucket was created by us, and our MLflow endpoint is in this artifacts path, and this was a particular run. Similarly, we have this estimator HTML. We can see these things. The best estimator has these parameters, right? So basically, this has certain things for exploration. Nothing we have not used it fully, and you can see the metrics here, which we have logged. And of course, I'll separately do a dive deep on MLflow features, but this is a basic MLflow environment which does the job. And then finally, we have registered the best model. We can go there also. It shows us the model artifact. So this is the version 1 of the model because we have done it only once. An input and output schema. You can see it takes in 13 features. It gives out a scalar value in that sense. So yeah, so that's all about this UI, and it works pretty smooth. It's running on Kubernetes. So anyways, I think that's all.